Good morning, students. Till now, we completed 3 units. Third unit is stresses in beams, that is bending stresses, flexural stresses, and shear stresses. Now we will discuss the unit 4, which is also related to the beams, deflection of beams. So it is a very important in the practical point of view. Deflection means, what is deflection? Deflection means it is a transverse displacement or vertical displacement of longitudinal centroidal axis of the beam after bending, which is measured in the direction perpendicular to the initial longitudinal axis of that beam before bending. So this is a deflected centroidal axis is called an elastic curve. The deflection is denoted by in this chapter with y, small y. Small y is the deflection. Clearly I will explain that what is deflection. Deflection means, for example, let us take a beam, simply supported beam. So simply supported beam, by applying the load on it, let us apply the load at center of the simply supported beam. By applying the load on simply supported beam, it bends like an arc of cycle, isn't it? Bends like an arc of cycle like this. It is the sagging bending moment. Due to sagging and bending moment, it bends like an arc of cycle. So the beam which bends like this, initial centroidal axis of the beam is horizontal before bending. So after bending, the centroidal axis, that means a neutral layer, will be deflect along with the beam. So this centroidal axis of the beam, position of centroidal axis of the beam with respect to the initial centroidal axis is called the deflection. For example, take the center position. Let us take the center position is C and the end point supports are B, AB. So position of the C initially at this place. Position of the C after deflection, that is after bending, at this place. So let us take this point as C dash. Initial position is C, final position is C dash of the same point before and after deflection. So this is the vertical displacement from this place to this place. The vertical displacement of C during bending of a beam is called the deflection. Here, in this case, simply supported with point load at center, in this case, the maximum displacement at the center. The maximum vertical displacement of the beam is at center. So maximum deflection occurs at the center. Let us take some other point on the beam. Let us take this point as a D before bending. After bending, the D position is at this place, vertical displacement. So this is the D dash. So from D to D dash, that vertical distance between D to D dash is called deflection of point D. Deflection of point D. This is the vertical displacement which is denoted by Y, which is also denoted by Y. This is the Y maximum deflection at the center. This is the Y somewhere else at a distance of something from one end. So D is deflected towards the vertical downward direction during bending of a beam. This vertical displacement is called the deflection. Clear, students? So that deflection, whatever the deflection central axis after deflection is called the elastic curve, because the beam is deflected within elastic limit. That's why the curve which is deflected after bending is called the elastic curve. The deflection is denoted by small y. That vertical displacement is represented by small y. Next, during deflection of beam, at every point, the beam is rotated with respect to initial position. During bending of a beam, every point in the beam will be rotated with respect to initial position. For example, take the same example. Simply supported beam, and beam bends like this. Angle of rotation or slope. Slope means the angle of rotation of beam. Initial position is horizontal, and after rotation is curve. This angle of rotation of every point is called the slope. How to find this angle of rotation? For example, let us find the slope at somewhere else. Here, what is the slope of the beam? If you want to know the slope of the beam at certain point, you should draw a tangent at this point. Tangent line for the curve, elastic curve. After bending, draw a tangent which extends and which makes an angle with a horizontal line, or initial position of the beam is called the slope at that point, or angle of rotation at that point. So how much slope of that curve after bending is means by drawing a tangent at the point on the curve, that tangent makes an angle with the initial position of the beam or horizontal line, which makes an angle of theta. This theta is called the angle of rotation or slope at this point. Clear, students? It is the inclination of tangent drawn at a point on the elastic curve. Elastic curve means the deflected centroidal axis is called the elastic curve. For that elastic curve, if we draw the tangent, it makes an angle of theta at certain with a horizontal line or initial position of the beam is called the angle of rotation or slope. It is the rate of change of deflection. It is also called the rate of change of deflection. In the mathematics, we know that what is the slope? Slope can be written as tan theta is equal to dy by dx. The deflection in the y direction with respect to x direction. Change in y direction with respect to x direction, tan theta is equal to dy by dx. For example, if you draw the slope at this point, let us take a vertical distance dy and a horizontal distance dx. This is the theta angle made by the tangent with the vertical. Let us take tan theta is equal to opposite side dy divided by horizontal side, adjacent side is dx. Dy by dx is the slope of the tangent. If the in practical case the deflection is very small, the slope is very small, tan theta can be write as theta. Tan theta ni manam slope eppudaithe small avutundo, chala slope chala takkuva untundo, tan theta ki equal. So theta is equal to dy by dx. Here theta is in radians. Theta is equal to dy by dx. Theta is equal to slope is equal to dy by dx. Slope of the curve at that particular point is theta. It can be represented as rate of change of deflection. Y is the deflection. X is the length along the beam. This is the x direction. This is the y direction. This is the deflection in the downward direction dy. So downward direction is positive here. Downward deflection is taken as positive, upward deflection is taken as negative. Here dy is the downward deflection, rate of change of deflection. Rate of change of deflection is called the slope. Rate of change of deflection into dy by dx. So it is denoted by theta. Clear, students? Theta and the slope of that bending curve at particular point is called the slope or angle of rotation, which is denoted by theta. It is the rate of change of deflection, or it can be defined as the inclination of tangent drawn at a point on the elastic curve is called the slope at that point. So curvature, what is meant by a curvature? Curvature means it is the rate of change of slope and it is a reciprocal of curvature, radius of curvature. It is a reciprocal of radius of curvature. What is radius of curvature? What is radius of curvature? Radius of curvature, let us take a simply supported beam again. If the simply supported beam bends like this, before bending, the beam is horizontal, its center of curvature is at infinity, and after bending, it bends like an arc of circle. The center of curvature comes nearer to the curve. So this is let us take O is the center of curvature. From that center of curvature to the elastic curve is called the radius of curvature. Radius of curvature. This is the arc of circle. If you continue this curve and it forms as a circle. So this is the part of the circle, that is the arc of circle. Center of circle forms, that's from center of circle O to that curve is called the radius of curvature. Reciprocal of this radius of curvature is called curvature. 1 by r is called the curvature. R is the radius of curvature, 1 by r is the curvature. It is also can be defined as the rate of change of slope, d theta by dx. D theta by dx is also called curvature. How to know that d theta by dx? Let us take two lines on the 2 points P and Q. I explained in the next slide. It is PQ is the 2 points on the curve which makes an angle of d theta at the center of curvature. The lines PO and QO subtended an angle of d theta at center. This is the arc of curvature. This is the arc of curvature. Arc length can be written as r d theta because r is the radius, d theta is the subtended angle. This arc length can be written as r d theta. R d theta, which is equal to because of very slow slope, it almost is equal to dx. This is the dx is a horizontal distance between the P and Q. So from this 1 by r is equal to d theta by dx. 1 by r is called the curvature. It is explained in the next slide anyway. So curvature is the rate of change of slope is called the curvature. Slope ante dy by dx is the tan theta or theta is equal to dy by dx. And curvature, therefore curvature from these two equations is equal to theta is equal to dy by dx, curvature is equal to d theta by dx. Therefore curvature is equal to, by substituting theta value at this place, d by dx of dy by dx, d square y by dx square. It is d by dx of d theta dy by dx. D by dx of dy by dx is represented as d square y by dx square. Second differentiation of deflection with respect to length of the beam is called the curvature. D square y by dx square is called the curvature. Curvature of that curve after bending of beam. Clear, students? So let us derive the equation for curvature. Curvature equation for this beam. So differential equation for elastic curve, which is also called a curvature equation. Now itself I written that curvature is equal to d square y by dx square. This is the curvature. What is the curvature equation in the next slide? We'll go to going to derive that curvature equation. It is also called differential equation of an elastic curve. Let us take the simply supported beam. This is the blue color. Simply supported beam, which is supported at A and B with support reactions RE and RB. Before bending, it is a straight AB. After bending, it is a curve. AB is the curve. and on which PQ are the points. Let us take 2 points on that curve after bending. Is PQ are points which makes an angle of which subtended an angle at O, center of curvature, is d theta. R is the radius of curvature. By extending this curve, which forms a circle having the center, from that center to curve is called the radius of curvature. Radius of curvature. This is the before bending the beam. This is the after bending the beam. This is the after bending. Okay, clear students from this diagram? Let us take the point P at a distance of x from the left end, left support. And dx is the horizontal distance between PQ. Horizontal distance between PQ dx. X is the distance from from left support. Distance of P from the left support. So it is enlarged view I drawn here. Enlarged view. This is the enlarged view. So P is the one of the point on the curve and Q is the another point on the curve after bending. PQ is the a curve of cycle or bending curve, which an angle which is subtended an angle at center of curvature O is d theta, and the radius of curvature is R. And this is the arc length. We can write from this arc subtended an angle of d theta at a distance of R. Therefore, the arc length becomes R d theta. This arc length is R into d theta. This is the sector length. Sector length, you know that from the mathematics. Sector length is R d theta, R theta, or angle made by that arc at center is d theta. Then its arc length is dr d theta. Okay. So this PQ, horizontal distance between PQ is dx, and the deflection of Q with respect to P is dy. Deflection of Q with respect to P, because the deflection of Q is more than the deflection of P towards the x direction. The deflection of Q with respect to P, we can take it as dy. Okay. From this, consider a simply supported beam subjected to a constant bending moment. By applying the load on this, it will be developed a bending moment at the end points. Bending moment at end points like this. Due to this constant bending moment, the beam bends like an arc of circle like this. Okay. Due to bending moment, it bends like an arc of circle shown in figure above. So consider 2 points P and Q on that elastic curve with the horizontal distance dx apart. With horizontal distance dx apart. Next, from the diagram we can write it as the arc length PQ is equal to arc length. How much it is? Arc length PQ is equal to R d theta. From this diagram, PQ arc length is R d theta. So in practical, the deflection is very small. If the deflection of this beam is very small, the horizontal distance dx is equal to arc length. Okay, arc length is equal to this is the d theta is very small. D theta is very small. This angle is very small. Therefore, the arc length is represented as dx. dy is very small. If deflection is very small, dy is very small between P and Q, because we are taking a small distance or small angle d theta at an angle of d theta. 2 points we are considering. Whenever the d theta is very small, PQ are very coincides with each other and deflection is very small. If dy is very small, the arc length is equal to a horizontal distance. Clear students? Generally, in practical cases, the beams are deflected a very small, not that much deflection takes place in the beams. So deflection, ఎప్పుడైతే deflection small గా ఉంటుందో horizontal distance అనేది r d theta కి equal చేయొచ్చు. Therefore, from that sentence, r d theta is equal to dx. I written here r d theta is equal to dx. From this equation, 1 by r is equal to d theta by dx. dx it తీసుకెళ్తే r it తీసుకెళ్తే d theta by dx is equal to 1 by r. In the above equation, the slope is decreases with respect to x. ఇక్కడ ఏం జరుగుతుంది? ఆ ఈక్వేషన్ లో జనరల్గా ఇక్కడ నుండి ఇక్కడికి వెళ్ళే కొద్దీ స్లోప్ అనేది డిక్రీజ్ అవుతూ ఉంటుంది. ఎక్స్ డైరెక్షన్ లో డిక్రీజ్ అవుతుంది. విత్ రెస్పెక్ట్ టు ఎక్స్, స్లోప్ ఈజ్ డిక్రీజెస్ ఫర్ ద సింప్లీ సపోర్టెడ్ బీమ్. Okay, here slope is more, here slope is less. Slope means the, now itself I explained that slope is the angle made by the tangent at that particular point. If we draw the tangent at point P, which makes an angle more angle when compared to if we draw the tangent at point A, which makes angle of 0 if it is horizontal. So angle is decreases towards the x direction. That's why I written that d theta by dx is minus with respect to x. So with respect to x, d theta అనేది minus కి తీసుకోవచ్చు. Therefore, based on the sign convention, the above equation can be written as 1 by r is equal to minus d theta by dx. Why that minus represents decrease in slope towards the x direction. So it is the magnitude wise these are equal, but direction wise these are not equal. Direction wise the minus must be represented in front of d theta by dx. So 1 by r is equal to minus d theta by dx. The slope is decreasing towards the x direction. That's why I represented it as minus d theta by dx, because 1 by r is always positive. It is a magnitude. A radius is always positive. It is not negative. 1 by r is also positive. To get the positive value, the minus sign will be converted d theta by dx as positive, because d theta is always negative. The negative is positive. So d theta is negative for the simply supported beam. That negative it will be positive. So minus d theta by dx is the decrease in, minus sign represents decrease in slope with respect to x. Let's take it as equation 1. Okay, from the bending equation, as we know that the bending equation is m by I is equal to E by R, or E by R equal to m by I, that is equal to sigma by y. That is the bending equation already studied in the 3rd unit, bending stresses. So from that bending equation, E by R equal to m by I, take the two parameters from that bending equation. From this equation, let us write 1 by R. If we write 1 by r is equal to m by ei, e comes to denominator. The m by 1 by r is equal to m by ei. That r is in this bending equation is also a radius of curvature. So 1 by r is equal to m by ei. Here the multiplication of e and I, this ei is called the flexural rigidity. The product of Young's modulus and moment of inertia is called the flexural rigidity. 1 by r is equal to bending moment by flexural rigidity. Take it as second equation. From these two equations, from equation 1 and equation 2, left hand side equal 1 by r, right hand side we can equate the right hand side parameters. Therefore, minus d theta by dx is equal to m by I, or d theta by dx is equal to minus m by I. From the equations 1 and 2, m by I is equal to minus d theta by dx. Therefore, d theta by dx is equal to minus m by ei. Take it as 3rd equation. So in this, d theta by dx is the curvature, rate of change of slope. M is the bending moment, E is the Young's modulus, I is the moment of inertia about neutral axis. So m by ei, m by ei లో ei అనేది ఫ్లెక్సరల్ రిజిడిటీ. గుర్తుపెట్టుకోండి, ఇది ei is flexural rigidity. Also slope, we know that slope is equal to theta is equal to dy by dx. Slope equal to, slope of that curve is dy by dx. Let us take again a curve. Here the slope of that this curve of slope of curve at point Q with respect to P is dy by dx, because it is makes an angle, some angle with respect to P. Slope between P and Q is theta, d theta. D theta is a subtended angle. The angle of curve, that angle of rotation of this curve is theta. Therefore, slope is equal to dy by dx. We can write as dy by dx. Slope is dy by dx. So from slope theta dy by dx, then d theta by dx can be write as differentiate this equation on both sides. On differentiation of this equation, left hand side d theta by dx is equal to second differentiation of this equation, that is the dy by dx differentiation, d square y by dx square. Simply I differentiate the above equation. Theta is equal to dy by dx, we know that, and d theta by dx can be write as d square y by dx square. Let us take, this is the equation 4. Now, from the equation 3 and 4, let us look the equation 3 and 4, left hand sides are equal. D theta by dx, d theta by dx. Therefore, we can equate the right hand side parameters. By equating the right hand side parameters from the equation 3 and 4, d square y by dx square is equal to minus m by ei. So d square y by dx equal to dx is equal to dx square is equal to minus m by ei. This is called the curvature equation or differential equation of an elastic curve. Okay, students, this is the basic equation for the fourth unit. Fourth unit ki ఇది చాలా important equation. It is called the differential equation for the elastic curve. It is also called curvature equation because d square y by dx square is the curvature. Curvature is equal to minus m by ei. Ei is the flexural rigidity. M is the bending moment at particular point. So the above equation is the curvature equation or it is the differential equation for the elastic curve of a bent beam. After bending of the beam, this equation can be applicable. It can be solved by solving this by solving the curvature equation. మనం దాన్ని సాల్వ్ చేసుకుంటే, solving means by integration of this differential equation. By solving the curvature equation, we will get the slope and deflection equations. ఈ curvature equation మనం 2 times solve చేస్తే, దీన్ని solve చేసుకుంటే, we can get the slope and deflection. In this chapter, mainly we are going to find the slope and deflection of a curved beam. Slope and deflection of curved beam. So mainly we are concentrating on slope and deflection. So by integrating the curvature equation once, we get, first time మనం integrate చేస్తే దీనికి ఒకసారి integrate చేస్తే on both sides, by integration of this d square y by dx square with respect to x, we can get dy by dx after integration, that is equal to minus integration of m by ei. Minus integration of m by ei. This dy by dx is also represented as theta. It is slope. Dy by dx is also called the slope. So theta is equal to minus m integration of m by ei plus c1. This c1 is the integration constant. First integration constant. This equation is called the slope equation. Slope is the dy by dx. After again integrate on second time by integrating the curvature equation twice. Curvature equation మనం 2 times integrate చేస్తే we get, again దీన్ని మళ్ళీ integrate చేస్తే ఏమొస్తుంది, dy by dx integration is y. Y is the deflection. Y deflection, dy by dx is the slope, which is represented as theta. So after integrating on left hand side, dy by dx will convert it into y. That is equal to minus second integration, that is 2 times integration in here, m by ei. The double integration of m by ei plus c1x. C1 is the constant. Integration of constant with respect to x is c1x plus another integration constant c2. So C2 is the another integration constants. These C1, C2 are the integration constants which can be evaluated or which can be determined from the beam boundary conditions. A C1, C2 ఎలా ఫైండ్ చేస్తాం, beam యొక్క boundary conditions బేస్ చేసుకొని C1, C2 లు మనం ఫైండ్ చేసుకుంటాం. This is the deflection equation. This equation is called the deflection equation. Y is equal to minus double integration of m by ei plus C1x plus C2 is the deflection equation. So upon integration of this curvature equation twice, we can get the deflection equation. Upon integration of this curvature equation once, we can get the slope equation. So integrate cheste slope equation vastundi, 2 times integrate cheste curvature equation ni deflection equation vastundi. These are the basic equations for this chapter. These are the 3 basic equations. Curvature equation. After solving the curvature equation, we will get the 2 equations, slope and deflection equations. Clear, students? Up to now, these are the equation generally used in this chapter, deflection of beams. So chapter is deflection of beams. In this chapter, we are going to find the slope and deflections both for a curved beam. Now, look at the next slide. Methods of determining slope and deflection. Slope is theta, deflection is y. The theta and y can be determined by these three methods. The three methods are double integration method, moment area method, and Macaulay's method, MACAULAY' method, Macaulay's method. These are the three methods. Generally, basic methods are used in the subject point of view to determine the slope and deflections. So first two methods are used to find the slope and deflections when one single load acting on a beam. ఒకే లోడ్ యాక్ట్ అయితే మాత్రమే ఫస్ట్ టూ మెథడ్స్ యూజ్ చేయగలం. మల్టిపుల్ లోడ్స్ యాక్ట్ అవుతే, మల్టిపుల్ లోడ్స్ అంటే ఏంటి ఆల్రెడీ మనం చదువుకున్నాం. మల్టిపుల్ లోడ్స్ ఇన్ బెండింగ్ స్ట్రెసెస్ అండ్ షియర్ స్ట్రెసెస్ లో మల్టిపుల్ లోడ్స్ అంటే ఏంటి, పాయింట్ లోడ్స్, నంబర్ ఆఫ్ పాయింట్ లోడ్స్ కానీ, ఆర్ పాయింట్ లోడ్ విత్ యూడిఎల్ కానీ, ఆర్ పాయింట్ లోడ్స్ విత్ యూవిఎల్ కానీ, అలా కాంబినేషన్ లోడ్స్ అప్లై అయినప్పుడు we cannot solve the problem by using first two methods. So multiple loads act అయినప్పుడు we can easily solve that problem by using Macaulay's method. It is the best method to solve, to determine slope and deflection for any type of beam and any type of load. So Macaulay's method is the best method when compared to the first two methods. First two methods used only a single load applied. Otherwise, we cannot use that that methods. Let us take the cantilever beam. Take the cantilever beam. For the cantilever beam with a single point load at pre-end W, like this, we can solve this problem for slope and deflection of this cantilever by using these two methods. Okay, by applying the load at this point, the cantilever beams bend like this. The maximum deflection occurs at the free end, and slope is also maximum at the free end. By drawing the tangent at this point after bending, it makes an angle with the initial position is called the slope at that point, theta. This is the y, deflection, the vertical displacement of this point. This vertical displacement is decreasing towards the fixed end. At the fixed end, the deflection is zero. At the fixed end, after applying the load, the deflection at this fixed end is zero. And also by drawing a slope at this point after bending, if we draw the tangent at this point, it coincides with the horizontal line. It coincides with the horizontal line. Therefore, slope at this point is also zero. So slope and deflections is fixed end zero. Slope and deflections is maximum at the free end after deflection. So ila oka load act అయినప్పుడు we can use these two methods. But number of points load, another load is also W1, W2, W3, like that multiple loads act అయినప్పుడు beam మీద we cannot use these two methods. We cannot solve that much of easy by using these two methods. So for multiple loads we can use the Macaulay's method is the best method. So some 2-3 problems we will solve the methods using first two methods, and remaining problems అన్ని కూడా మనం Macaulay's methods యూజ్ చేసే సాల్వ్ చేస్తాం. ఎందుకంటే it is the best method కాబట్టి we follow that method. Okay, మల్టిపుల్ లోడ్స్ యాక్ట్ అయినప్పుడు మనం ఈజీగా సాల్వ్ చేసుకోవడానికి Macaulay's మెథడ్ బెస్ట్ కాబట్టి Macaulay's మెథడ్ యూజ్ చేసుకొని సాల్వ్ చేస్తాం. ఓకే, సో సైన్ కన్వెన్షన్స్ ఒకసారి చూద్దాం ఈ చాప్టర్ లో. వాట్ ఆర్ ద సైన్ కన్వెన్షన్స్? Downward deflection is positive. Beam bends downwards, it is taken as positive. If beam bends upwards, it is taken as negative. So upward deflection is negative. Clear students? Beam downward deflect avute positive ga తీసుకుంటాం, upward deflects avute it is negative in this chapter. So next, second one, clockwise slope is positive, counter clockwise slope is negative. Clockwise slope అనుకోండి it is positive గా ఉంటుంది. నెక్స్ట్ కౌంటర్ క్లాక్ వైజ్ డైరెక్షన్ లో అయితే, యాంటీ క్లాక్ వైజ్ డైరెక్షన్ లో అయితే నెగిటివ్. ఏంట కౌంటర్ క్లాక్ వైజ్? Again I will explain with a simply supported beam. After bending the beam is like this. For example, if we want to find the slope at this particular point, draw a tangent at that particular point. this tangent makes an angle with a horizontal position theta, or if we draw the theta at this place, okay. So by drawing this tangent which makes an angle of theta with a horizontal initial position, this is the clockwise slope. Clockwise slope means this is the clockwise, in this direction is clockwise, in this direction is anti-clockwise. At this point the clockwise slope will be developed. That's why the slope is positive at this point. If we take this point at this place on the curve, if we draw the tangent at this point, which makes an angle of theta with the initial position, it is the anti-clockwise direction. Anti-clockwise slope it is. Anti-clockwise slope is taken as negative. Okay? From center to left hand side is the positive slope. From center to right hand side is negative slope will be occurs in the simply supported beam when the load is point load is acting on the at the center. Okay, clear? That is the sign convention. Clockwise slope and anti-clockwise slope. Clockwise slope is positive, anti-clockwise slope is negative. Downward deflection is positive, upward deflection is negative. Beam always bends downwards. Beam always deflected downwards upon applying the loads. That's why the downward deflection is positive. If any case the beam bends upwards, is that means beam bends like this. Beam bends like this, it is called the hogging bending moment. Hogging bending moment is negative, and upward deflection is also negative. In the previous chapter, we followed the sign convention that sagging bending moment is positive, hogging bending moment is negative. Okay? Sagging bending moment at the downward deflect అవుతుంది. Downward deflect అయినప్పుడు అది పాజిటివ్ గా తీసుకుంటాం. Hogging bending moment negative కాబట్టి upward deflection is also negative. So we are following the same conventions as that of the previous chapters. Next, third sign convention ఏంటంటే the distance of x is measured in positive x direction. Always we looks the section, we take the section at particular point, the section must be from the left hand side, that is the positive x direction. Yeah, in the previous chapter we take the sections from the right hand sides, but in this chapter we go for a left hand side. From the left hand side, that the positive x direction is taken as a distance. The xx distance is positive x directions. So positive x direction is positive, negative x direction is negative itself. These are the sign conventions. Again, I will explain the third sign convention is, if we take the simply supported beam, by taking an xx section, if we consider the xx section, this xx section must be considered at a distance of x, from the left hand side, left hand support, not from the right hand support. The axis increases towards the right hand side. Axis increases. X is 0 at this point. X is L, length of the beam at this point. X is 0, increases from 0 to length of the beam towards the right section. If you consider the xx section here, x is more than the previous case. This x is more than this previous case, and xx considered at the right support. X is equal to L. That means x must be considered in the positive x direction. This direction x is increases. Okay, that is the case which is taken in the third sign convention. That is the third sign convention. The distance of section x is measured in positive x direction only. These are the sign conventions. Okay, students. This is the worked example. Let us look in the next class that worked example. Up to now, we derived the bending equation. That is the not bending equation. That is the differential equation for an elastic curve, which is basic equation. It is also called the curvature equation. D square y by dx square is equal to minus m by ei is the curvature equation. By using that curvature equation, we solve for the slope and deflection equations. Dy by dx and y is the slope and deflections. In that, after integrating, the C1, C2 are the integration constants which can be determined by the boundary conditions of that particular beam. Let us look the boundary conditions in the next class. What are the boundary conditions for the cantilever beam? What are the boundary conditions for simply supported beam? Let us explain. I will explain in the next class. Okay. And this methods to determine the slope and deflections are three methods: double integration method, moment area method, and Michaelis method. The first two methods are used to find the slope and deflection if the single loads acting on the beam. The Michaelis method, third method, is used to find the slope and deflections for any type of beam and any type of loads. And sign conventions. In this class, we have discussed up to now. I'm closing this class. Okay, students, bye. Let us close this class, and I will explain the remaining worked examples in the next class. Okay, bye.